Is this one good? Hopefully, it's good. How about this one? How about this one? This translates to the square root of 4 third to the third power, and then that equals 8. Okay, this one I said to make a sketch. I had to make a sketch. I'm like, okay, well, let's think about this. I'm not sure. This tells me to move to the left 2, if you remember this. And this tells me to move up 3 with the parabola. It's a parabola because it's squared. So I move left 2 and up 3. My domain, x can be anything. Y's will be greater than or equal to 3. Okay? Good with that? All right. Hey, so what we're doing is we're doing exponential growth and decay today. And you've done it before. We did it a little bit in algebra. I don't know about whether you do it in geometry or not, probably not, but that's what we're doing. So, exponential function, are you ready? It's when the variable is the exponent. It's when the variable is the exponent. That's what an exponential function is. So, for example, an exponential function could look something like this. There's an example of an exponential function. The variable is the exponent. Here's another one. Y equals 4 to the x. You could, if you had to, think of it like this. Because there's an A, you notice there's an A and a B here. And so 1 would be A and 4 would be B. So you might think of it like that sometimes as well. Okay? So this is just the growth factor is what you're multiplying by. It's the B. Asymptote. You remember that fun word from algebra? Say it. It's a fun word, isn't it? Asymptote. If you really, really, really want to impress your parents at dinner tonight, say we learned about asymptotes today. Do you know what that is, Mom and Dad? No, they won't, I bet. Some of them might, but okay. It sounds scarier than it is. It's so hard. Okay, so graph the function. Now, you have options. This one's a pretty easy one, just to make a table. Yes, I do want a few specific points when you're graphing these. Does anybody remember what an exponential function looks like? Yeah, it kind of comes straight from somewhere and climbs up. Growth goes up, decay goes down, which we're going to do in 7-2. This is a growth function. Okay, so if I made x 0, what's y going to be?
0.
Anything raised to the 0 power is 1. Any number, always. So there's 1 point right there. 0, 1. Okay? If I made x 1, what would y be? 1, 5 would be 5. So over 1, up 5. Okay? Now let's do a negative just for the fun of it. So what would y equals 5 to the negative 1 be?
1/5.
Yeah, would be 1/5. Okay, so negative 1 to the 1/5, you just kind of guess. Now here's the thing that I might be slightly picky about. With an exponential function, you can see it's coming from the left here. It's never, ever, ever going to go below that x-axis, ever. So don't be lazy with your drawings. Okay, and be careful with that. Therefore, the x-axis is called the what? Do you remember? The asymptote. I don't really know the right way to say it, but I think that's how you say it, asymptote. That is the asymptote. Yes, it is a line that a graph approaches more and more closely but never crosses. That's why I said be careful with your drawings. In exponential growth and decay, there is this line that it will never go below, okay, or above, or whatever. So that's called the asymptote. All right, now let's do this one. Y equals 2 to the x. Let's make a graph. Now, you guys, if you can't, can you use the table on the calculator? That's fine with me. Get a few points off the calculator. Plug in 0. What is y going to be if x is 0? 1. Okay. Let's do, just for fun, negative 1. What would y be? I'm a little bit out of order here, but you'll forgive me. Negative 2. What would that be? Yeah, you do. What does that equal? 1/4. Okay, and then you could do 1. What would 1 be? 2. So let's just see what these look like when we plot them. Okay, 0, 1, negative 1, 1/2, negative 2, 1/4. Look at how it's approaching. It will never, ever, ever go below. Y will never be less than 0. It will never be 0 even. Okay, for this one. Over 1, up 2. So again, I'm coming from here. I'm not going to go below that x-axis, and it climbs up like that. So therefore, the x-axis is called the what? Yes. Again, because it's the line it approaches but never crosses. Okay, before we turn this over, I want you to think about something. You notice the y-intercept in both of these graphs. Where's the y-intercept? It's at 1, isn't it? Look at the equations. How could you get from the equation the y-intercept, do you think, if you remember from above what I was talking about? Could we rewrite this as y equals 1 times 5 to the x?
Yeah.
And remember that a is going to be your y-intercept, and b is what it's being multiplied by. That's only if you don't add or subtract anything to it. Okay? If it's in this form, that'll tell you what your y-intercept is. Got it? Same with this one, y equals 1 times 2 to the x. Just saying. Something to think about. Okay? All right, turn it over. Now, I just want you to write the general form up here because I feel like it's missing in these notes. So here's the general form of a longer exponential function. Y equals a times b x minus h plus k. Right on. Now let's talk about what each part means. What does the a mean? Yes, before we have any of this movement. Okay, it starts here, and then this movement will affect the y-intercept. But so the a is the original y-intercept. The h makes it go left or right, and the k makes it do what? Up or down. Okay. 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 Sorry. All right. So let's talk about this then. We're just kind of shifting these exponential graphs is what we're doing. So what is my y-intercept? It is 1/3. Y equals 1/3 because this is y equals a times b to the x. There's nothing that makes it shift up and down. We can make a quick table. We can get it off the calculator. I'm just going to give you some of the points for the sake of time. There's 3 points. So if we plot those points, we have 1, 1, 2, 3, and 0, 1/3. Look at that. The y-intercept is 1/3. What's the asymptote in this graph? Still? It is the x-axis. Okay. So let's talk about the domain. What could x be in this graph? Remember, it just keeps going this way, and it keeps going. I should put an arrow here. It does go this way. X could be anything. X could be any real number. The domain is any real number. What's y going to be? Greater than what? Greater than 0. It's never ever going to be 0. It's always going to be just slightly greater than 0. This is always based on the asymptote. Okay? All right, let's do another one. So here, negative. What's it going to do to the graph? It's going to make it go down. Reflection. Remember, like when we had parabolas and the a was negative, it made it go down, right? Same thing in these graphs. So I'll give you some points. Here, a is -1. I just wanted to point that out. A is -1. It's going to make it go down. So we have 1, -7/2, 0, -1, and -1, -2/7. I just came up with those points. You just spend time doing that. You can do that on your own. And let's graph that. And it really should go down. Because of the negative, it should make it reflect over the x-axis. Okay? So 1 negative 7/2 is the same as negative 3.5. Yes? It's over 1 down 3.5. 0, negative 1. Oh, look, it is. It's my y-intercept. Yes? And then negative 1, negative 2/7 is going to be kind of, I don't know, right here. Now be careful again. It's never, ever, ever going to go above that x-axis because that's my asymptote. Okay? What is the domain? What are the possible x values for this graph? Anything. What's the range? Yes, y is less than 0. Okay? Oh, look at it. It's a doozy. We got some movement going on here. So, we started where, for y-intercept, we started where? At 2, didn't we? We started at 2. This is going to make it do what? Right on. That plus 2 is going to make it go left because we had to stick in a positive h here. Excuse me, a negative h here. So it's going to make it go left 2. What is this going to do to it? Up 1. And then 4 actually makes it stretch, doesn't it? It makes it climb quicker. It's going to be an even steeper exponential function because you're multiplying by 4 every single time. So it makes it climb really quickly. So I'm just going to kind of sketch the original. It's sort of like this. That's the original. That's y equals a times b to the x. Okay, now let's start with right here. It goes up 1 and left 2. So that's kind of where my y-intercept went. Up 1, left 2. And just for the heck of it, let's make a little table so we can get some specific points. Negative 2, 3. Negative 3, 1.5. Did I not go? No, it went up 1. Let's see what happens. You're right. You're right. Let's see. Let's see what happens here. Negative 1, 9. Yeah. What does the what? The E is usually the y-intercept, but you're right, Tracy. Let me think about this. Let's see what happens. Negative 2, 3. You're right. This is where it's supposed to be. Thank you. Negative 2, 3. Negative 3, 1.5. What is going on? It is Monday. Oh, yeah, that's right. Negative 3, 1.5, it's right. And negative 1, 9 goes way the heck up there. So it kind of climbs like this. Kind of looks like that. So this is my asymptote. That 1 right there kind of tells me where that is. So that's what it looks like. Okay, again, the domain could be anything for here. X could be anything because this keeps going this way and that keeps going that way. So X could be anything. The range is all going to be what? Greater than what number? Right, okay. Is this familiar? You guys kind of remember this? You pretty much did this stuff before. All right, exponential growth model and compound interest model. Let's talk about making money here. Okay, exponential growth model. I'm going to tell you what the different parts of this are. Again, A is the initial amount, just like the y-intercept, initial amount. R is the rate. T represents time. And this is the tricky part. This whole thing together, it's not tricky, it's just people forget. The whole thing together is the growth rate. It's called the growth rate. Whatever number you're multiplying by every single time, that's called the growth rate. So let's use this first, and then we'll go back and use that. In 1970, the population of Kern County, California, where Bakersfield is located, was about 330,000. Oh, that is going to be my A, my initial starting amount. From 1970 to 2000, so we have T, time is 0 in 1970. What would T be in 2000? 30. I'm just going to mark that right there and see if that helps me later. The county population grew at an average annual rate of 2.4%. Now you have to be careful. We can't use it in this form. We always have to convert the percent to what? Decimal. So it's going to be R equals 0.024. Okay, now let's see what we got to do. We have to write an exponential growth model giving the population P of Kern County T years after 1970. So we're just writing a general model where we could plug any number in for T after 1970. So we're going to leave T in this first part. They're asking us to do. Okay, T years after 1970. So remember, we're going to use this right here. Y equals, what's my initial amount? 330,000. And then I have 1 plus, what's my rate? 0.024. And I'm going to leave it as T because I want to keep a model where I can plug in any year since 1970. That's what they're asking me to do here. Now, I would make this prettier by combining these two. 1 plus 0.024. It would be 1.024 to the T. That's what I'm looking for. Now, as a reminder, this right here is the growth factor. And I know it's growing because this number is greater than what? Anybody know? 1. It's called a growth factor. I know it's growing because that number is greater than 1. More than 1, so I know it's growth. Because I'm multiplying by a number that's going to make it bigger every single time, right? Okay. All right, so it says, about how many people lived in Kern County in 1990? Therefore, I'm going to use what for T? T equals 20. So I'm going to plug it into my model. I didn't even do the math. Somebody do it for me.
530,000.
Okay. So P is your principal, the initial amount. So let's say your rich uncle gives you $2,000 for your 16th birthday, and you stick it in a bank account. That's your principal. Starting dollars. Okay. Again here, R is your rate. N is the number of times it's compounded. That means how many times you're going to get interest in a year. Times compounded. Yes, there's two places where N is here. The time compounded means how many times a year you're going to get interest on your money. It could be once a year, it could be twice a year, it could be every month, that would be 12 times a year. We're going to talk about that, okay? That means the bank gives you interest on your money however many times a year. And then T represents what? How long it's in there, time. Okay? Let's just practice this down here. You deposit $5,500, oh, that's my P, in an account that pays 3.6% annual interest. That's my R. It's going to be 0.036. Find the balance after 2 years if the interest is compounded with the given frequency. So here my T is 2. Now, there's these words, semi-annually, which I didn't even include here. But how many times a year do you think semi-annually is? Twice a year, semi-annually. So this tells me that N is equal to 2. That's how many times a year I'm going to get compounded. So I have enough information to do this. I'm going to plug in my P, my R, my T, and my N to this equation. Okay? So A equals 5,500 times 1 plus my R is 0.036 divided by my N, which is 2, raised to the N times T, 2 times 2. How much money am I going to make? So this is going to equal approximately $5,906.82. That is a huge rate of return. Lucky for you if you find something that gives you that much money in a year, in 2 years even. Okay, so this one, monthly. So what would be different about this equation? My N would be what? How many times a year? 12. N would be 12. Okay? I'm not going to go through all that, but the only thing that changes is that your N changes. I wrote these down here. Daily, doubt you'll find any place that will give you daily, but that would be 365. Yearly would be 1. Bi-monthly. Bi-monthly means every other month. That would be 6 times a year. Weekly is 52. Bi-weekly is every other week, so that would be 26. And quarterly is 4. Monthly is 12. So these are things you might see. I just wrote those down for you. Okay? All right.